Welcome back to the Deep Dive, where we take a stack of dense sources, slice right through the noise, and extract the most compelling nuggets of knowledge for you.
It's great to be here.
Today, we are undertaking a deep dive into attention deficit hyperactivity disorder, or ADHD, a condition that affects millions. But we are approaching it from a surprisingly physical, biological perspective.
That's right. We're moving beyond just the brain and into the body's clock.
Exactly. So when you think about ADHD, you naturally picture the core diagnostic criteria. That challenge with sustained attention, the difficulty regulating impulsivity, and for many, that restless, relentless hyperactivity.
The classic symptoms.
But let's pause right there. If you or someone you know manages ADHD, I guarantee you've also noticed a less discussed but, well, highly prevalent symptom. Profound and consistent trouble with sleep and overall timing.
It comes up constantly in clinical settings.
Okay, let's unpack this. What if the difficulty maintaining focus and managing energy isn't just about a deficiency in neurotransmitters, but about the brain being consistently out of sync, running on a biological schedule that is, permanently phase delayed?
That concept that the ADHD brain is constantly operating in the wrong time zone is precisely the compelling thesis of the source material we've synthesized today.
And what are we looking at?
We are looking at a perspective paper by Liu and Fabiano that pulled together massive amounts of convergent evidence. Their core argument is that circadian rhythm dysfunction is not merely a frequent side effect of the stress of having ADHD. It is a clinically significant and highly prevalent phenotype.
A phenotype?
Yes, an observable biological characteristic in a substantial subgroup of individuals with the disorder.
A phenotype is a great term for this because it moves it from a subjective report, I have trouble sleeping, to an observable, measurable feature. So our mission for this deep dive is clear. We are going to synthesize 3 distinct lines of evidence: the behavioral, the hormonal, and the molecular, all linking ADHD directly to what is known as a chronic evening chronotype.
Right, and once we establish that the internal clock is definitively late, we're going to explore the practical, highly personalized treatment frontier known as chronotherapy.
Which is really about interventions designed to shift the internal clock earlier to fundamentally improve daytime functioning and symptoms.
Exactly. We are moving the conversation past the casual acknowledgement that people with ADHD just have trouble sleeping.
Right.
We are arguing that their fundamental biological timing is off, and that timing deficit is a core driver that exacerbates their daytime struggles with executive function, energy regulation, and emotional control.
So we're looking at a systems problem, not just an attention problem.
It's a systems problem, absolutely.
Yeah. Let's ground this in the real-world experience of the listener, the learner. We need to start with the sheer scale of the problem because the statistics here are not just high. They are, they're overwhelming.
They really are. I mean, if the majority of a population experiences a symptom, it should cease to be viewed as a secondary complication.
It has to be part of the core issue.
Indeed. The sources indicate that profound sleep issues are the rule, not the exception. We're talking about up to 80% of adults with ADHD who suffer from insomnia and general sleep disturbances.
80%. And for kids.
And astonishingly, the rates are nearly identical in children, with up to 82% reporting the same persistent issues.
80%. That is statistically almost universal. I mean, if 4 out of 5 people who are diagnosed with the disorder are struggling profoundly with a specific issue, we have to assume that issue is intrinsic to the disorder itself.
Can't just be a random comorbidity.
No way.
And we can narrow that down even further than general insomnia. When researchers look specifically at timing, they find delayed sleep-wake timing in up to 73–78% of both children and adults with ADHD.
So it's not just taking a long time to fall asleep.
No, it means their natural body cues push them toward going to bed and waking up later than the societal standard.
I think what's crucial here, as the source material pointed out, is that these high prevalence rates hold up even after controlling for other confounding variables.
That's right. And that's so important. Researchers are always careful to control for common comorbidities like generalized anxiety or depression, which are, well known to interfere with sleep.
Of course.
Yet, even when controlling for those conditions, the high prevalence of delayed timing persists.
And what does that suggest?
It strongly suggests that the timing disruption is linked specifically, mechanistically, to the ADHD pathophysiology itself, and is not simply a product of feeling stressed or sad.
That brings us to chronotype, which is this popular term for this phenomenon. Let's clearly define what evening chronotype means biologically and what the systematic review found in this population.
Sure. So chronotype refers to your individual genetically determined preference for activity and sleep timing throughout a 24-hour day.
Morning lark versus night owl.
Basically, yes. We tend to fall along a spectrum. Morning larks prefer early starts and early bedtimes, and night owls prefer late starts and late bedtimes. The comprehensive systematic review cited in the sources established a robust evidence base for evening chronotype predominance in the ADHD population.
So the default setting for the ADHD brain is night owl, operating on a consistently late schedule.
It seems to be yes.
But this isn't just about preferring to stay up late to watch TV. This is biological, right?
It is entirely biological. The sources indicate that approximately 3/4 of adults who are diagnosed with ADHD in childhood show objective evidence of phase-delayed circadian rhythms.
Objective evidence.
Meaning it's measurable. Their entire internal schedule, their peak energy, their body temperature minimum, their hormone release is measurably shifted later than their neurotypical peers.
Let's connect this back to our listeners. So if you have ADHD, your internal system is optimized for later hours.
Right.
You might finally hit your stride, feel productive, and capable of sustained focus right around 9 p.m. or 10 p.m.
Exactly, when everyone else is winding down.
Meanwhile, the school bell rings or the corporate meeting starts at 8:30 a.m., which biologically is still the middle of your subjective night.
That is the core of the mismatch and why it's so debilitating. You are attempting to perform high-level executive function task planning, organization, impulse control at the time when your body is biologically programmed for low-level function or even sleep inertia.
So it explains why early mornings are not just unpleasant, but a profound systemic struggle that feels like constantly fighting gravity.
It does. The challenge isn't a lack of motivation. It's a fundamental conflict between a rigid, society-imposed schedule and the person's hardwired biological timing.
That context is vital. We've established the behavioral pattern, the epidemic of eveningness, and the massive challenge of conforming to a daytime world. Now we must move beyond self-reports and look inside the body. What are the objective markers that confirm this clock is physically and measurably delayed?
So now we transition from the observable symptoms to the underlying biology. To confirm a phase delay, we need to look at specific biological markers. And the mechanism starts with a hormone that regulates the transition to night, melatonin.
Melatonin, okay, so it's the chemical signal of darkness. It doesn't actually make you sleep, right?
Yeah.
It just tells the body that the biological night is starting, preparing the system for rest.
Exactly right. And the gold standard measurement researchers use for timing this transition is the dim light melatonin onset, or DLMO.
DLMO.
This is the point where the melatonin concentration in saliva or blood rises reliably above a certain threshold in dim light. It's the true start of the biological night, independent of when you decide to go to bed.
And in individuals with ADHD, this DLMO is.
It's consistently and significantly delayed.
And the data gives us those precise numbers for the delays, showing a clear difference between children and adults.
It does. In children with ADHD, the DLMO is delayed by approximately 45 minutes compared to neurotypical controls.
45 minutes, okay.
But notice what happens as that individual progresses into adulthood. The delay pushes out to approximately 90 minutes later.
90 minutes, wow. That's a profound biological time shift.
It really is.
If a healthy person's clock starts at, say, 9:30 p.m., the person with adult ADHD isn't starting their biological clock until 11:30 p.m. I have to wonder, though, why does the delay nearly double in adults? Why the additional 45 minutes?
That's a key question, and the difference suggests a cumulative effect.
Hmm.
While the underlying biology, that 45-minute delay, is present in childhood, the combination of adult responsibilities, career demands, social lives, and the cumulative effects of chronic self-imposed sleep restriction to meet morning obligations may push the clock even later.
So life just makes it worse.
The constant conflict between their internal rhythm and the required external schedule exacerbates the phase delay over time. The adult brain is simply more chronically sleep-deprived and has had more years of fighting its own biology.
That makes perfect sense. The environment is continually pulling them later while they struggle to pull themselves earlier. Now, there's an interesting wrinkle the sources brought up regarding the production of melatonin itself and how it interacts with standard ADHD treatment.
Yes, this was fascinating. Some studies found abnormally high melatonin levels present during the daytime in children with ADHD.
During the day, so the signal is just messy.
It suggests not just a timing issue, but potentially a regulatory issue. What's truly fascinating is that this daytime abnormality improves significantly with methylphenidate treatment, a common stimulant medication for ADHD.
Okay, that raises a critical question for me. If we see high melatonin during the day, which improves with the stimulant, couldn't that mean the clock disorder is a result of the ADHD brain malfunction rather than an underlying cause?
That's a thoughtful challenge, and it really shows the complexity. It confirms the bidirectional nature of the relationship.
It's not a one-way street.
Right. It's not necessarily A causes B. It suggests that the same central nervous system dysregulation that causes the attention deficit might also be fouling up the system that regulates hormone release, leading to erratic or late melatonin signaling.
And the stimulant tightens everything up.
The stimulant might be tightening up the overall CNS control, which then, incidentally, stabilizes the melatonin profile. Regardless of causality, it points to a deep physical connection between the two systems.
And speaking of physical connections, we even have a structural correlation with the organ responsible for melatonin synthesis, the pineal gland.
Correct. The source indicates a specific morphological difference. Individuals with ADHD have been found to have smaller pineal gland volume compared to healthy controls.
A smaller pineal gland.
And this is the crucial correlation. Pineal gland volume positively correlated with eveningness.
So the physical structure of the brain itself might be predisposing someone to be a night owl. That's a powerful, tangible connection that grounds this phenotype in anatomy.
It is.
But the disruption isn't confined to the sleep hormone. To truly understand the 24-hour pattern, we have to look at the hormone that regulates waking, cortisol.
Absolutely. While melatonin signals the night, cortisol, often mislabeled only as the stress hormone, is essential for preparing the body for the metabolic demands of waking and activity.
It's the get-up-and-go hormone.
It should surge in the morning, the cortisol awakening response, to switch the system from rest to alert.
And in ADHD.
The research demonstrates that ADHD is associated with blunted, meaning smaller and delayed cortisol rhythms. A meta-analysis confirmed that children with ADHD exhibit lower basal cortisol levels, particularly when they should be high in the early morning.
This is where that conceptual visualization, Figure 1, becomes so instructive. It depicts the contrast in the 24-hour hormonal profile. If you walk us through that dashed line profile, we can see exactly why mornings are so miserable.
Okay, so in the conceptual Figure 1, the dashed line representing the ADHD profile shows 3 key hormonal timing deficits compared to the solid line, which is the neurotypical control.
Right.
First, we see the delayed DLMO that we discussed. Second, you often see reduced nocturnal melatonin amplitude. The signal is not only late, but perhaps less intense.
Okay, so a weaker go-to-sleep signal.
And on the cortisol side, which governs the morning, the visual shows a later and flatter morning cortisol rise and peak.
So the person with ADHD is getting a weak, late start-your-engine signal from their cortisol. It's like trying to start a car on a cold winter morning. The engine just sputters.
That's a perfect analogy.
That sluggish, hard-to-wake feeling, that slow transition to alertness, is entirely biologically grounded.
Precisely. If your essential wake-up alarm, the morning cortisol surge, is late and blunted, you are fundamentally ill-prepared to engage in the high-level executive function tasks that school or work demand.
You're starting the day at a deficit.
You spend the first 2 or 3 hours of your day fighting a biological drag that your peers are not experiencing. This entire pattern, the late-night signal, the weak morning signal, implies a central deficit in the brain's master timekeeper. The suprachiasmatic nucleus, or SCN.
The SCN is the key component here. For those unfamiliar, let's take a moment to define its role and why its compromised ability to entrain is such a central finding.
Of course. Think of the SCN, which is located in the hypothalamus, as the body's orchestra conductor.
Okay.
It receives light signals from the eyes and coordinates the timing of every cell and every process in the body, ensuring everything from hormone release to body temperature minimums happens at the correct 24-hour interval.
And when we say its ability to entrain is compromised, what does that mean?
It means the conductor is constantly playing half a beat later than the rest of the musicians, and sometimes the individual musicians, the peripheral clocks in the liver, lungs, etc., aren't listening very well and fall out of sync.
So it's systemic chaos.
It results in the systemic desynchronization we see, leading to the late DLMO and the delayed cortisol peak. It is a central clock management issue, not just a localized hormone problem.
That's a great analogy. It helps us move from thinking about chemical signals to thinking about systemic desynchronization. But to truly understand the root cause, we have to go even smaller. We need to look at the machinery running the clock inside every cell, the molecular feedback loops.
Right. We must reinforce that this is a cellular level timing issue. The 24-hour cycle is ultimately driven by core clock genes that oscillate in an interlocking positive and negative feedback loop.
Okay, so this is getting into the weeds. What are the key players?
The key players are brain and muscle RNT-like 1, or BMLL1, and period circadian protein homolog 2, or PER2.
BML1 and PR2. Can you walk us through how those two work together to maintain a rhythm?
Certainly. In the positive loop, the BML1 protein pairs up with another protein, CLOCK, and this pair promotes the transcription or turning on of the PER and CRY genes, including PER2.
So BML1 is the accelerator.
You could say that. As PER2 builds up in the cytoplasm, it acts as a brake. Once its concentration reaches a critical level, it moves back into the nucleus and inhibits the action of the BML1 key OLOC pair.
Yeah, so it shuts itself off.
It does. This inhibition causes the production of PER2 to slow down. As the existing PER2 breaks down over a few hours, the inhibition lifts and the BML1 KLOC pair starts ramping up production again. This cycle takes precisely about 24 hours to complete.
Giving us the circadian rhythm.
Exactly. So BML1 KLOC are the accelerators and PRCRY are the brakes, creating a continuous, self-regulating 24-hour oscillation. If that mechanism is working properly, the cell keeps perfect time.
And in people with ADHD.
Now, when researchers looked at individuals with ADHD, they found attenuated or weaker and desynchronized BML1 PR2 readings in oral mucosa samples.
Oral mucosa, so cheek swabs. Why are those samples important?
Oral mucosa samples are used because they are easily accessible and contain peripheral clocks, the clocks in the cells outside the SCN. Finding attenuated rhythmicity here suggests that the weakness in the timing signal is widespread. It's not just the SCN that's slightly compromised, but the local clocks in the body's tissues are also running weakly or out of sync.
And the crucial finding, the one that ties the cellular mechanism directly to the disorder.
This is the smoking gun.
Okay.
Clinical symptom severity tracks precisely with reduced PER2 rhythmicity.
So the weaker the clock gene's rhythm.
The worse the patient's symptoms of ADHD are. This is it. Objective behavioral reports, delayed hormonal markers, structural brain differences, and now molecular clock disruptions all point to a widespread, prevalent circadian phase delay in the majority of the ADHD population.
The evidence base is now incredibly strong.
There.
The problem is, for a huge percentage of people, a delayed clock.
It really is.
Therefore, the logical and elegant therapeutic approach is chronotherapy interventions designed explicitly to shift that internal clock earlier or phase advance the rhythm.
Right, we're treating the clock.
We are going to examine the clinical trial evidence for the three major intervention types, starting with the most straightforward, melatonin supplementation.
Melatonin is the most studied chronotherapeutic agent in this population because it's a direct signaling molecule. The trials show clear efficacy in phase shifting the clock, which is step 1.
But does it help the ADHD symptoms?
The subsequent translation to core ADHD symptoms, however, takes longer and varies by individual.
Let's detail the results of the adult trial first, as it offers the most direct proof of concept for phase correction.
Okay. In a randomized controlled trial involving adults with delayed sleep phase and ADHD, researchers used a surprisingly low dose, just 0.5 milligrams of melatonin per night.
Very low dose.
And this advanced the DLMO, that critical measure of biological night, by a significant 88 minutes.
88 minutes, and we just said the adult delay is typically around 90 minutes.
Exactly. So a simple, low-dose intervention achieved a near-perfect correction of the biological timing.
But did this translate to real-world function? Did they feel better?
Yes. This intervention resulted in a measurable and clinically significant 14% reduction in overall ADHD symptoms.
14%. How should we think about that? What does a 14% reduction feel like?
Well, to put that into perspective for the listener, that could be the difference between chronically missing deadlines and managing them most of the time. It might mean losing one debilitating symptom, perhaps the persistent trouble initiating tasks from a list of 7. It's a tangible functional benefit stemming directly from fixing the clock.
Okay, now let's look at the children's trial, which involved 101 medication-free children who had chronic sleep onset insomnia.
Right. That trial was designed to look specifically at the sleep benefit. Children were given a dose of 3 to 6 milligrams nightly for 4 weeks.
Higher dose for kids.
Yes, and they observed a highly significant 44-minute advance in the DLMO, while the control group, by contrast, actually experienced a 13-minute phase delay during the same period.
So they got even later without it.
They did. Furthermore, total sleep time significantly improved by 20 minutes for the melatonin group, versus a loss of 14 minutes in the control group. So a clear sleep benefit, clear phase advance.
This is where we must address the symptom lag. If the clock shifted and sleep improved, why did the core ADHD symptoms, attention, and behavior not change within that 4-week period?
That's a fascinating finding, and it really speaks to the neuroscience. The clock system itself, the SCN and hormone release, is fast to adjust.
Okay.
But the complex neuronal networks that underpin sophisticated functions like cognitive control and attention require much longer, sometimes months, to fully recalibrate and integrate the benefits of consistent, correctly timed sleep.
So 4 weeks just wasn't enough time.
The 4-week trial was likely too short to capture the resulting improvement in executive function.
That necessity for sustained long-term correction is supported by the follow-up data on that same pediatric cohort, right?
Absolutely. The long-term follow-up is arguably the most persuasive piece of evidence. 65% of the participants continued taking daily melatonin long-term.
And for those kids.
For those continuing treatment, positive improvements were reported in behavior by 71% of participants and mood by 61%. The sustained long-term phase shifts seem to unlock those real-world functional benefits.
What happened if they stopped?
This makes it a truly scientific finding, the relapse data. When children discontinued the treatment, 92% immediately experienced a phase delay in their sleep again.
Wow. So it bounced right back.
It demonstrates that the melatonin was actively maintaining the correct phase alignment, and the underlying biological tendency to delay was still present.
So the science is clear that melatonin is a powerful chronotherapeutic tool, but the caveat remains. We still need more data on the precise application.
Yes, we still need more trials defining the optimal dose. Why did 0.5 milligram work for adults while kids needed 3 to 6 milligrams? We need to know the optimal timing relative to the individual's pre-treatment DLMO and the required duration for sleep gains to translate fully into core symptom improvement.
It's all about precision.
The future of this treatment is precision, identifying exactly which individual is a melatonin responder and tailoring the dose and timing perfectly.
Okay, moving on to the second major chronotherapeutic intervention, bright light therapy, or BLT. We know light is the strongest Zeitgeber, the strongest time cue the body has.
Light is dominant. It acts like a reset button for the SCN. I mean, studies in healthy populations show just how fast it works. A week of maximizing natural light-dark cycles could entrain a roughly 2.6-hour earlier DLMO in healthy adults.
2.5 hours just from light.
We are talking about massive biological shifts simply from managing light exposure.
If that's the general population, what about the specific results for light therapy in ADHD patients who are already struggling with severe delays?
The initial research is highly encouraging. One finding showed that combining bright light therapy with melatonin yielded the largest phase advance observed, approximately 2 hours in adults with ADHD and delayed sleep phase.
So stacking them has a huge effect.
That multimodal combination maximizes the push forward.
And what did the specific pilot study on morning light alone demonstrate?
A pilot trial used 2 weeks of morning bright light, specifically from a high-intensity 10,000 lux lamp, on adults.
The kind people use for seasonal depression.
Exactly. This advanced the DLMO by 31 minutes and the mid-sleep time by 57 minutes. But here's the key part. They found a significant dose-dependent interaction. The size of the phase advance, the shift in the clock time, correlated directly with improvements in the hyperactive impulsive subscores of the ADHD rating scales.
That's critical. It suggests the hyperactivity might, at least in part, be an expression of being chronically out of sync.
It could be.
If you are operating on a 90-minute delay, constantly forcing activity when the body is demanding rest, the result is an agitated, dysregulated state. Treating the timing literally reduces the impulsivity and hyperactivity.
It supports the idea that what we call hyperactivity could be a combination of restlessness and dysregulation stemming from chronic biological misalignment. And this is further underscored by the seasonal relevance of light therapy.
Let's elaborate on that seasonal link. Why does light exposure matter more in fall and winter for this population?
Well, during fall and winter, natural light cues are weaker and darkness comes earlier. For someone who already has a delayed clock, this weakness means their SCN has an even harder time synchronizing to the day.
It has less to work with.
Right. The sources highlighted that trials conducted during these darker periods found that a circadian phase advance was the strongest independent predictor of improvement across various ADHD indices.
And this connects to seasonal affective disorder, or SED.
It does. The overall rate of SED is high 27% among adults with ADHD, with women being at the highest risk. The research suggests that the circadian disturbance significantly mediates the relationship between ADHD and those seasonal depressive symptoms.
How so?
The reduced light in winter deepens the phase delay, which exacerbates the ADHD symptoms and can trigger depression. Bright light therapy in the morning effectively mitigates this by replacing the missing light cue.
So we have chemical with melatonin and light with BLT, both supported by objective data. Now, let's discuss the highly pragmatic route. Behavioral interventions, which are accessible to everyone and often represent the first line of defense.
Right, and behavioral changes, often underestimated, are incredibly powerful because they govern the Zeitgebers, all the external cues the body uses to set its clock.
So what did the research show?
A randomized trial involving 244 children with ADHD looked at a simple behavioral sleep intervention, just 2 sessions providing structured strategies from psychologists or pediatricians and a follow-up call.
And what was the 6-month outcome of that relatively brief, low-cost intervention?
It was pretty amazing. At 6 months post-intervention, the children experienced significant improvements, not just in sleep quality, but also in the overall severity of ADHD symptoms, general behavior, quality of life, and functioning.
All from just a couple of sessions.
It demonstrates that targeted, expert-guided behavioral routine changes can produce lasting, real-world improvements, reinforcing the power of regularity in managing the disorder.
The sources also mentioned exercise as a powerful adjunct tool, even if dedicated ADHD trials are still emerging.
That's right. Exercise is a known Zeitgeber. It influences body temperature and metabolism, which feeds back into the SCN.
It tells your body it's daytime.
Research suggests that both morning and evening exercise seem to advance DLMO in those who are later chronotypes. Since most people with ADHD are late chronotypes, exercise, especially timed intentionally, could be a helpful non-pharmacological adjunct tool for phase advancement.
Finally, we must spend dedicated time on the night owl protocol. This study involved healthy late chronotypes, but it provides a near-perfect blueprint, a manual for anyone with ADHD who wants to reset their system without immediate reliance on medication.
This was a compelling study. They took 22 night owls and put them on an intensive, structured behavioral intervention aimed at rapidly phase advancing their rhythm. They didn't just suggest vague improvements, they gave them a clear 8-strategy manual for resetting their lives.
Okay, let's break down those 8 strategies in detail and analyze the logic behind them, maybe grouping them into the main categories of intervention.
We can group them into 3 conceptual areas: light management and fixed scheduling, metabolic timing, and behavioral hygiene.
Let's start with light management and scheduling.
Okay, that group consisted of 4 key strategies. 1, wake up 2-3 hours earlier than normal. 2, maintain a fixed wake time daily, even on weekends.
That's the hard way.
It is. 3, maximize morning light exposure immediately upon waking. And 4, reduce evening light exposure and practice screen hygiene, like wearing blue light blocking glasses or using filters.
That fixed wake time seems counterintuitive to many people struggling with sleep. Why is the fixed wake time arguably more important than the fixed bedtime?
The fixed wake time is the anchor. It's what regulates the timing of your morning cortisol surge and, crucially, when your SCN starts its countdown to the next night's DLMO. If your wake time drifts, your clock is constantly shifting.
It's the reset button every morning.
Getting that bright light cue immediately upon waking locks in the start of the day. Conversely, restricting evening light stops the light signal from delaying the onset of melatonin. These are direct, powerful inputs to the SCN.
Excellent. What about group 2, metabolic timing?
This involved avoiding late dinners and avoiding caffeine after 3 p.m.
Timing your food and drink.
These inputs affect peripheral clocks. Eating late sends a metabolic signal that delays the winding down process, often overriding the SCN's signal to rest. Caffeine is an obvious one, but the 3 p.m. cutoff is specific because caffeine has a very long half-life.
So a 4 p.m. coffee can still mess with you at midnight.
It can still interfere with deep sleep architecture, contributing to morning sluggishness.
And finally, group 3, behavioral hygiene.
This included morning exercise and avoiding late afternoon naps.
Why the morning exercise specifically?
Exercise, as we noted, is a Zeitgeber that advances the clock, making the morning timing highly strategic. And avoiding late afternoon naps is critical because a long nap can reduce sleep pressure, the drive to sleep built up throughout the day, allowing the night owl to comfortably stay up even later, exacerbating the phase delay.
That sounds like a complete overhaul of lifestyle. What kind of objective biological results did this structure yield in just 3 weeks.
The results were extraordinary and rapid. In just 3 weeks, the night owls shifted their DLMO by about 2 hours.
2 hours, that's a massive biological reset.
It is. Their wake-up time advanced by nearly 2 hours, and their peak cortisol advanced by 2.2 hours. They had fundamentally reset their entire biological day using non-pharmacological inputs.
And did that dramatic biological shift translate to functional subjective benefits, even though they weren't ADHD patients?
Absolutely. They saw highly significant psychological benefits. Subjective depression scores decreased by approximately 58%, and stress scores decreased by about 40%. They also reported improved cognitive and physical performance. This study provides powerful proof of concept. Structured, low-cost guidance centered on regulating light, food, and sleep timing is incredibly powerful, providing a strong, actionable blueprint for managing the circadian phenotype within the ADHD population.
Okay, so if we synthesize everything we've talked about, sections 1, 2, and 3, what's the big takeaway?
The core conclusion stands. Circadian rhythm dysfunction is highly prevalent, affecting 73% to 80% of patients, and is clinically meaningful in a substantial proportion of individuals with ADHD.
Right.
This supports a model where timing disruption plays an essential role in the underlying pathophysiology, exacerbating core symptoms.
We have to reiterate the caveat the authors made, though. They are not proposing reclassifying ADHD exclusively as a circadian disorder.
That distinction is crucial. The paper recognizes that the core attention and executive function deficits still exist, likely due to other neurological factors. However, the recognition of the delayed clock as a highly prevalent and impactful phenotype is necessary because when it is present, it demands a targeted, specialized intervention chronotherapy to optimize the patient's system.
You can't just ignore it.
We cannot expect standard treatments to be maximally effective if the body is biologically exhausted and misaligned.
This evidence warrants a complete change in how clinicians approach assessment and treatment. What is the pragmatic, behavioral-first clinical pathway that Lou and Fabiano propose for the future of ADHD care?
They recommend a structured 4-step approach that shifts the standard diagnostic paradigm. This is about changing the clinical conversation.
Well, what's step 1?
Step 1. Routine screening for sleep and circadian disturbances in every ADHD evaluation. Not just asking, do you sleep well, but specifically using validated questionnaires to check for chronic phase delay and insomnia symptoms.
Let's make it standard practice.
This must become standard intake procedure.
Step 2.
Phenotypic characterization. This involves moving toward objective measurement.
So getting the real data.
Exactly. This means using chronotype assessments, detailed sleep tracking via wearables, and ideally, when feasible in specialized clinics, objective DLMO measurement. You need to know precisely how far delayed the patient is before you can determine the dose and timing of a phase-advancing treatment.
Right. It's moving from general observation to targeted precision.
That's the goal.
Okay, step 3.
Implementation of key behavioral strategies first. This utilizes the powerful low-risk blueprint we just discussed.
The behavioral first mandate.
Yes, clinicians should be guiding patients toward fixed wake times, maximizing morning bright light exposure, strictly restricting evening light exposure using screen hygiene, and regularizing all environmental zeitgebers, the cues that signal time to the brain. This is the low-cost, high-impact foundational work.
And finally, step 4, integrating the pharmacological intervention.
Selective use of low-dose melatonin, specifically for individuals with confirmed or probable DLMO delays, where behavior and light alone were insufficient to advance the phase adequately.
So it's an addition, not the first choice.
It is positioned as an adjunct tool, maximizing the biological benefit after the lifestyle framework has been established.
What's compelling is the emphasis on pragmatism and the strong safety profile of these interventions. We are talking about leveraging natural cues before relying on high-dose pharmaceuticals.
The authors emphasize that chronotherapeutic interventions are pragmatic, scalable, generally low risk, and have a very strong safety profile.
That makes them a pretty attractive option.
An extremely attractive and responsible addition alongside standard ADHD treatments like stimulants. We are addressing a fundamental biological mismatch that standard treatments often overlook, making the overall system more receptive to treatment.
So we are essentially optimizing the environment and the timing, making the brain ready to accept the standard chemical treatments, rather than constantly fighting against a delayed clock.
We are optimizing the system before we maximize the pharmaceuticals. We are treating the night to maximally improve the day.
That seems like it would have to change the long-term prognosis.
It changes the long-term prognosis for compliance and overall functional outcome.
This deep dive has completely recontextualized how we should view ADHD for a massive subgroup of people. We moved from the startling statistic that up to 80% of people with the disorder struggle with profound sleep issues, to the objective, measurable findings of a 90-minute biological phase delay in adults rooted in hormonal and molecular clock disruptions.
And critically, we have explored the powerful promise of personalized chronotherapy using targeted melatonin, bright light exposure, and the structured behavioral blueprint of the night owl protocol to shift that clock forward.
The evidence is just. It's convergent and strong.
It is. For many, fixing the attention deficit may start quite simply with fixing the sleep timing deficit. This brings us right into the realm of precision medicine, which is the future of treatment.
Which means the focus has to be on identifying exactly who is dealing with this delayed clock.
Precisely. The research demonstrates that certain individuals respond specifically and measurably to phase-advancing treatments. And those phase advances are often linked directly to improvements in core symptoms, particularly hyperactivity and impulsivity.
So we are moving away from a one-size-fits-all diagnosis.
We have to. So here is the final thought for you to mull over.
Okay.
If the majority of people with ADHD have a fundamental timing disorder, and if the effectiveness of treatment for a patient depends on whether or not they have a delayed clock, which all this data strongly suggests is the case,
Right.
then wouldn't routine circadian phenotyping, that objective testing of the internal clock, prove absolutely essential for diagnostic clarity, treatment selection, and optimization in the future?
It seems like it would have to be.
We have to ask,
Right.
Can we truly treat ADHD better by first treating the night?
A question that fundamentally shifts the clinical perspective. That was our deep dive into ADHD and the delayed biological clock. Thank you for joining us.
Thank you.
We'll see you next time.